Welcome to module 4.5. In this module, we talk briefly about browser isolation. So far, we have been looking at isolation in the operating system, sandboxing, and various ways of containing privilege and so on, so that we can do less harm if one component is attacked by some kind of a cyber attack. But in case of browser, you will see that there is a lot of design that has gone in for isolation, because the content that we bring in into our browser are mostly from untrusted sources, and therefore anything that comes in with when we surf a website, we might want to isolate that in such a way so that you do not have a risk of that bug or that some kind of an exploit that comes with the content of the website does not affect the rest of the system. So, in a way analogous to operating system. So, in operating system we saw that subjects are processes and they have user ID like UID or SID in case of Windows, and they have discretionary access control, which if you remember, which means that once you have the correct user ID and you access some resource, you are free to pass that resource to somebody, and that is not prevented by the system. The objects in operating system are files, network resources such as sockets and so on, and vulnerabilities are that we often download programs and we often get programs which are buggy. So, untrusted programs, and the kind of things that we see in untrusted programs are buffer overflow, integer overflow, and so on and so forth. However, in case of web browser, the subject is web content, for example JavaScript. So, the way web content is separated from each other is by a notion of origin. So, we will talk a little more about what origins are. Mostly it is an indicator of where the provenance or where it came from, and a browser normally enforces a mandatory access control. The objects we are looking into is document object model or DOMs. DOMs are the data structures that basically is an internal representation of the document that is being frames. For example, frames are sort of an unit of isolation in case of web browser, and then for storage we see cookies and some local storage. The vulnerabilities in the web are various types. So, depending on what you have brought in, you might have some exploits built into the document that you brought into your browser. For example, cross-site scripting, implementation bugs, and so on and so forth. The web browser enforces an internal policy, and as we will see later that different web browsers based on the company that makes the web browser has different policies, and therefore sometimes the policies have to be changed, and over time for example Firefox today has a different security policy than it was when it first came. If the browser implementation has bugs, then you can also use all the program vulnerabilities that we saw before, buffer overflow and so on and so forth, and that could break the isolation and so on. So in this part we were not talking about those browser implementation errors. We are talking about browser architecture, the security policies, and the way the browser handles content, and how the browser makes communication between different windows or different frames. Those kind of places there could be vulnerability due to proper design, proper secure mechanisms, and those are the things that we will focus on in the next few modules. Now, the security policies could be various kinds. So, for example, in browsers, any of you who have browsed a website, most of the websites have multiple frames. So, and the frame idea came later, not in the beginning, but later on the frame idea came from Netscape, and then now it is one of the main components of a web browser. So, frames actually initially was to create different segments of the display where you can put different contents and you can independently change the content, so that you do not have to reload the entire page when some part of the frame needs to be updated. For example, in the very early days there was iGoogle, that was a sort of like a customizable website you can build for yourself, and it would allow you to create different frames, one frame showing weather data, some frame showing you stock market updates, and some frame showing you maybe some other kind of information. And so these contents of the different frames come from different sites, and therefore they cannot trust each other. So therefore there has to be some policy that restricts the frame to frame relationship. For example, if you have content in frame A and content in frame B, and frame A is actually a JavaScript, can it actually script something to manipulate the content of frame B? So that is sort of like you can express that as some kind of a predicate, whether two frames can script each other to change the internal data structure of the document being displayed in the other frame. Can navigate basically means that suppose I am in frame A and there is frame B, can I change the display on the frame B? Like, in other words, can I change the origin of content? So if one frame is showing Microsoft content, another frame is showing Google content, can the Microsoft content have some script element that will say that go to frame B and change the origin from Google to Microsoft? So if that is allowed, then this predicate holds, otherwise it won't hold. And we will see that in most cases there are very severe restrictions on how one frame can navigate another frame's content. Frame principal relationships are like, can a frame A read the cookies from site S, because different sites store cookies to remember who you are and so on, so that next time you go to that website the cookie is sent along with your request, and that is a way of creating state in a rather stateless protocol, which is HTTP. So similarly, can you write on the cookies from site S from frame A? So these are the various components of the browser security policy. So now Chromium security architecture comes from Google, and it kind of has become a standard architecture in which what you do is that you have a browser kernel, and the browser kernel has full privileges to access your file system, your network socket and so on. And then there are rendering engines. The rendering engine and depending on implementation and so on, let us say up to 20 processes, and they are sandboxed, which means that they cannot have full privilege of interacting with your system, and any time they have to interact with your file system or sockets and so on, they have to ask the browser kernel to do that on their behalf. And this is a way to keep the least privilege principle working in the browser architecture. Although nowadays the most browsers are not anymore supporting plugins, but in the middle, in the evolution of browser history, the plugins were very popular, and normally there would be a process corresponding to a plugin, and it will have full privileges of browser, and now that led to a lot of vulnerabilities. And nowadays I think the most recent version of Chrome, for example, does not support or the plugin support. So in Chromium, the communication architecture is that there is inter-process communication between browser kernel and the various frames. So the frames, as I said, are sandboxed. So here is a frame which is sandboxed, and here is a frame that is sandboxed, and this is called a broker because it basically enforces the security policy of the browser. So what it does is that every time, so inside each of this sandboxed environment, you also have policy engine client. So, this is the where the policy is written and the policy is interpreted by the policy engine, and every time a communication happens between a frame and the kernel, the policy engine has to check whether what is requested by this is actually being is actually permissible by the security policy. So, there are various design decisions that go into a browser design. Now, one of the major thing is compatibility, because a browser is not useful if it cannot display most of the content that is available out there in various web servers. Now, the other thing that the designer of the web services and web server applications have to rely on the browser security policy. So, they have to make some assumptions that certain things will not be interfered with by another frame. For example, if you are doing banking in one frame, you are typing in your password for your banking, another frame should not actually be able to see it, and that is assumed by the designer of the banking interface, because if your browser is allowing that, then you are in trouble. And as I said that since the browsers have to be compatible with the existing sites in most cases, so you cannot just tomorrow decide that I will completely change the browser architecture to make it more secure. You have to work with what you have, and that rules out the clean slate approach. So, the browsers in a sense, only the renderer, which is sandboxed, can parse HTML, JavaScript, etc., and kernel enforces the high level security policy, or what we call coarse grained security policy, and renderer enforces more finer grained security policies. And so, and the design, one of the design objective of a browser would be to minimize user decision. So, if the user asks you at every point that are you going to allow this or that, most users of browsers will not have any clue whatsoever about what to do. So, you have to design your browser security policies in such a way so that the user has to make very few decisions or no decisions. So, the task allocation is that rendering engine does for example, HTML parsing, style sheet parsing, image decoding, JavaScript interpretation, regular expression design, layout of the of what you are going to see, the document object model, the parsing of the document like HTML or other documents, and then put them in a document object model data structure, rendering, SVG or vector graphics, XML parsing, XSalt, and so on. Browser kernel maintains the cookie database, history database, password database, window management, location bar, what you see on top of the safe browsing blacklist. So, when some website is blacklisted, that information comes to the kernel. The kernel is supposed to show you some kind of information about that. Network stack, SSL TLS, which is the secure socket layer that you use for HTTPS, disk cache, download manager, clipboard, and so on. And both are responsible for URL parsing, Unicode parsing, and so on. So, this is the more or less the division of work between the kernel and the different rendering engines. Now, what is done for isolation or for sandboxing, it obviously is working on top of an operating system. So, and then as I said that each of the renderers are in themselves sandboxed, and so to create that sandbox you have to basically rely on the underlying operating system. So, in case of Windows, for example, each of these renderers run inside a Windows job object, and then it is actually each renderer run on a separate desktop, because in some versions of Windows you if you are on the same desktop you can do inter-process communication between those entities, and therefore it's better, it's safer to delegate them on different desktops. It's basically a desktop object, so you don't necessarily see them on different desktop. You actually use the security token that actually is made restricted. So remember we talked about the security tokens with SID inside it in Microsoft. So but they actually adjust the security level into a deny only restriction, and for that they call the adjust token privileges, and as I said, it runs on Windows job object, and therefore it cannot create. So its Windows job object itself is sort of like a restricted in privilege, so they cannot create new processes, read or write on clipboards, and so on and so forth. Now it turns out, and this is a little bit dated information, that the CVEs or the vulnerability that have been disclosed, you will see that for example in Internet Explorer at this point in time, and this is probably 2009, there were 4 browser CVEs where there were 10 renderer CVEs, and some were unclassified, whether it is a browser or renderer problem. Firefox 17 versus 40, Safari 12 versus 37, and that means that the number of bugs that could be quite dangerous are not uncommon, are quite large in number. And there are also among these there are multiple arbitrary code execution vulnerabilities, as you would see in browsers here, 155, renderer 9, 19 and 10. Now browsers have security is a big issue for Microsoft, for Google and for Apple and so on. So there are a lot of work that goes into this browser security, and I don't here have the latest CVE numbers, but the number of such bugs have been dropping quite a bit. So in summary, in lecture 4 or module 4, we saw 5 modules, and we talked about security principles, which are isolation, principle of least privilege, and we explained that with the QMail example, and access control mechanism. We saw access control matrix, access control list, and capabilities based access control. OS mechanisms that uses various techniques for isolation. For example, in Unix, setuid is one way of maintaining privilege, escalate or de-escalate privilege, and so on. In Windows, it's a more token based system. And then we kind of in the latest one, we kind of talked about browser security architecture, but in the next lecture we will go more into the web security, and then we will see some more of it. So in lecture 4 we saw total 5 modules. So first one was about secure architecture principles, isolation and least privilege. This is very important part of the course. Understanding isolation and principle of least privilege, and how privileges are escalated, how privilege escalation attack happens, and this is something you should study very carefully, and consulting with other material that will be posted. Access control concepts are very important, because that is a way of keeping resources safe, and if that can be breached by privilege escalation or escaping from isolation, then you are in quite a bit of trouble. And then we talked about Unix and Windows access control in very brief, and then we talked a few more issues in access control, and then we introduced you to the browser isolation.